Okay, so the last section that we look at is solving problems with more than one. We're going to add, oh, it's frozen. We're going to add the word, I'm going to add the word right triangle here because you can only use SOHCAHTOA and you can only use a squared plus b squared equals c squared if the triangles have a 90-degree angle. Okay? So sometimes the hardest thing to do is to see where both the triangles are, and sometimes it's not too bad. So in this first example, you want to find the length of xy. And you'll start to notice that in these bigger questions, they start to use lengths like xy instead of a little letter, because how would you describe this side? Would you use a little w because it's opposite w, or would you use a little z because it's opposite z? It could be both, right? So we often have in a question like this that they give you xy instead of a little letter because it's really easy to see that we want to find this length from here to here. Okay? Now, color coding things. Can you see both right-angled triangles? I'm going to draw one in red. Can you see this is one right-angled triangle? And one in green. This is the other right-angled triangle. And it will be a 90-degree on the other side because a straight line, if you think of your protractor or your clinometer, a straight line is 180 degrees. So if one side of the straight line is 90, the other side has to be 90 as well, because a straight line will always add up to 180 degrees. So I'm going to pick a letter for what we want to find. I'm going to pick the letter x there, because that's what we want to find, from x to y. Is that x part of a right-angled triangle? Yes, that x is part of the red right-angled triangle. When we look at that red right-angled triangle, can you see that you have a 22 degrees? You could find the other degree there, but you have no sides whatsoever on that red triangle. And in order to find something with SOHCAHTOA, you need two pieces of information, an angle and a side, or two sides. And since we have no sides whatsoever, there's nothing that we can solve for on the red triangle yet. But if we look at the green triangle, can you see on the green right-angle triangle, you do have an angle and you do have a side. In fact, on that green triangle, you could solve for everything on that green triangle. Because that's what we were doing last class, right? The last class questions were solve the triangle, find everything on it. But in these questions, with solving for more than one triangle, if you want to, you can solve for everything, but there's going to be one piece of information that's going to be helpful. So if I look at what I can solve for, and I'm just going to put dots, can you see on the green triangle, you could easily find this angle, because they add up to 180. You could find this side, because you could use adjacent over hypotenuse, and you could find this side, because you could use opposite over hypotenuse. Which one should we find? We should find, I'm going to highlight it, you're right, we should find this one, right? Why would we want to find that one? It's the only one that's connected to that red triangle. So I'm going to pick a different letter, because I've already said I'm going to make x this one. What letter would you like to use? A little y? Okay. So I'm going to put a little y right here. And then, in the green triangle, can you see that the 8.4 is the hypotenuse? And the little y is opposite the 20. So if I write out SOHCAHTOA over here, I know the hypotenuse in the green one, and I want to find the opposite side, so I should use my definition for sine. So I write out my definition for sine, that sine of 20 degrees is the opposite, which is little y, over the hypotenuse, which is 8.4. I want to get the y by itself. So the opposite of dividing by 8.4 would be to multiply both sides by 8.4. And now I can go to my calculator and type in 8.4 sine of 20. Apparently that calculator is being slow, so I'll do it on this one. Try it on your own calculator. Did you get the same numbers as I did? 2.87 dot, dot, dot. I'm just putting those dot, dot, dots because I don't want to round until the very end. Okay. Now that I have that, now I can go to my red triangle. 2.87. Did I say something different when I said it? No? Okay. Now we go to our red triangle. What do we want to find? We want to find x. Can you see that x is your hypotenuse of your red triangle? So we're going to either have to use SO or CA, sine or cosine, because they involve a hypotenuse. What angle do we have on the red triangle? We have 22. And we now know the yellow line, which is y, which is the adjacent side. So I know the adjacent side on the red one, and I want to find the hypotenuse. That means for writing out my definition, I'll want to use cosine. So I write out the definition of cosine. Cosine of the angle of 22 degrees is the adjacent side, which is 2.87 dot, 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 divided by the hypotenuse, which is x. Now, what do we want to do? We want to get that x by itself. But do you see that that x is in the denominator? So we're going to multiply both sides by x. And then have to divide to get x by itself. You would also have to divide by the cos of 22. So now that my calculator is working, I can do the first one again. Remember, in the first one, we had 8.4 sine of 20. And this is where we got the 2.87 dot, dot, dot. And now we want to do 2.87 divided by cos 22. On almost all calculators, if you have the answer, you can just hit divide. It takes that answer and says, what would you like to divide that answer by? We can take that answer and divide by cos of 22. And we get 3.0985. Does it say what to round to? Nearest tenth. How would you round this to the nearest tenth? 3.1. Was there units? .1 centimeters. So we're going to look back at this whole question. First of all, what did we do? We noticed where the two right-angled triangles were. There was the green one and there was a red one. We labeled the side we wanted to find. We chose x. But unfortunately, at the beginning, the x was part of the red triangle, and we didn't have enough information in the red triangle. But when we looked at the green triangle, we had one side and one angle. You need to have at least one side to figure anything out. And so we could have solved everything on the green triangle. But we didn't bother to find W to Z because it wouldn't help us with the red triangle. So we looked at the question and said, the W to Y, that's going to be part of my red triangle as well. So that makes the most sense to try to solve first. And I highlighted that with the yellow line. Then, once we had that, we were able to go back to the red triangle and solve for x like we wanted to begin with. So these questions that have more than one right triangle, you have to use the one triangle to help you figure out the other triangle. Now the next level of difficulty, more than one triangle, and it's a word problem that you have to read and draw it yourself. So, the angle of elevation to the top of an apartment block from a window in a nearby building is 28 degrees, and the angle of depression from the window to the bottom of the apartment block is 34 degrees. The window is 24 feet off the ground. How tall is the apartment block? So we have to draw a picture, okay? Take out a pencil, and you draw a sketch of the picture on your own first, because this is really like you have to problem solve and draw that picture. Once you've got it drawn, I will draw a picture as well, and we can compare to see, did we have the same idea? So read the question and draw a diagram or a picture with all the numbers labeled. So you have two buildings. You got a blue building and maybe a green building. And there's a window on the blue building. And from that window, I'm going to draw a horizontal line. The angle of elevation to the top of the building is 28 degrees. So I know that this is 28 degrees. And the angle of depression from the same window to the bottom of the building is 34 degrees. The window, the 24, is right from here to here is 24. 24 what? Feet? So that's a little dash there. Wow. That was a big 24 feet would be from this dot to this dot. Okay? How many right triangles got made? 3 of them. There's one, you could put a right angle here, a right angle here, a right angle there. But technically, I would probably use this green one here and purple one here. And because this window is 24 high, does it make sense that this is also 24 on that side? So which is the part that they share? They share this line is going to be the one that's going to be helpful to find. And in order to find out how tall the apartment block is, can you see that what I need to find is this part of the purple triangle? And if I find that x, that's not going to be the answer. The answer is going to be that x plus the 24. Okay. But we can't, if you look at the x, right now, that x is part of the purple triangle. Can you see that you don't know any sides of the purple triangle? So I have to find that yellow line because I have enough information to solve the entire green triangle. So just like last time, you're okay with the letter Y? So I'm going to make that little yellow line Y. Now, in the green triangle, so I'll switch to my green pen, which definition, SOHCAHTOA, which one should I use? Right? You have the opposite, so it's either sine or tangent. And it's going to be, this is not the hypotenuse, right? This is the hypotenuse here. So the y is the adjacent side. So you're right, in the green one, we want to use tan. So I'll write out the definition of tan. Tan of your angle, 34 degrees, is your opposite side, which is 24, divided by your adjacent side, which is y. We want to get y by itself. It's on the bottom, so we have to multiply both sides by y. Awesome. And then, can you see that if you wanted y by itself after you multiplied, you would have to divide by the tan of 34. So you would have 24 divided by tan of 34. Go to our calculators. 24. 35.6 or 35.58. I'm going to go dot, dot, dot. Because we'll keep all of our decimal places. Now that we found y, you have enough information to go to your purple triangle and solve. So I'm going to switch colors to purple. We want to find x. Can you see that x is opposite the 28? Which side do we know? We figured out y, the adjacent side. So which definition do we have to use for purple? We have to use tan again. So we set up our tan definition for purple. Tan of 28 degrees. The opposite of 28 degrees is the x that we want to find. The adjacent side is the 35.58 dot, dot, dot that we solved. Can you see that if you want to get the x by itself, it's already in your numerator, that's good, but we're dividing by 35.58. Opposite of dividing by 35.58 would be to multiply both sides by 35.58. And so we would get x is equal to 35.58 dot, 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 multiplied by tan of 28. So my calculator already had the 35.58. I can just say I need to multiply that answer by tan of, oh, I forgot the angle, 28. And we push enter, and we get 18.9 is x, 18.92. Oops. X equals 18.92. So the total height is going to be 24. Does it say what to round to? No. So I'd do 2 decimal places if it doesn't say. Do we have units? Feet or meters? So we always check our question for units at the end. Okay, next one. Again, you have to draw it. You have a building. And then on the roof of the building, there's a flagpole. Perfect. With a flag on it. And it says that from a point 125 meters away, So we go out 125 meters. The angle of elevation from the top and bottom, we got to the bottom of the flagpole and to the top of the flagpole, are 37 and 40 degrees. Angle of elevation is always from the horizontal. So does it make sense? I'll label this one in blue that this is 37 degrees, and I'll label this one in green. This would be the 40 degrees. Does it make sense that this tiny little angle, if you wanted to, in between would be 3 degrees? Okay? So, most students see two triangles, but most students don't see two right triangles. Can you see this? The easy triangle to see is the purple one. Did everybody see this triangle here with 90 degrees there? Then the second triangle that students see is this one with the 3 degrees, but it's not a right angle triangle. So that's a problem, because you can only use SOHCAHTOA and a squared plus b squared equals c squared if you have two right angle triangles. So the question is, can you see the second right angle triangle? Both triangles, kind of this big one here. That is the second right angle triangle. What do we want to find? Okay, we want to find the height of the building and the height of the flagpole. Okay, I'm going to call this little x, it should be in purple because it's on the purple one. Okay, little x is on the purple one. I'm going to call this whole length in green from there to there y. And does it make sense that the height of the flagpole will equal the whole height y minus x? Does that make sense as an idea? So, can we find out any of those letters, x or y, directly? We can find x. Okay, let's go to purple. Let's write out here, first of all, off to the side here, SOHCAHTOA, that's my definitions. So we're solving the purple x. We know the angle, right? Is 37 degrees. X is the opposite side, and we know the adjacent side. So we're going to use, in purple, tan. And we can write out that tan of 37 degrees, opposite side is x, adjacent side is 125. How do I get x by itself? Multiply both sides by 125. Type that into my calculator. So 125 times tan of 37 94.19. Okay. Go to my green triangle. Can you see that you can already solve for the green part? Okay? It was kind of nice. Do you see that when you have two triangles like this, what's the side that's shared? This is the side that's shared between those two. And it was kind of nice in this question that that was what was given to us already. So we didn't have to do any extra work to figure it out, because we already knew that that yellow line was 125. So now when I go to my green one, if I want to find y, again, I'm trying to find the opposite side, and I know the adjacent side. So for green, I'll use tan as well. This time the angle is 40 degrees. Opposite is y. Adjacent's 125. I want to figure out what y is. So I multiply both sides by 125. And 125 tan of 40 gives me 104.89. What did this question ask us to find? Find the height of the building. So can you see that we have the height of the building already? That was the purple X. Does it say what we need to round to? No, so I'm going to do 2 decimal places, 94.19. And we also wanted to find the height of the flagpole. That we have to do some work, right? We have to take 104.89 minus 94.19. So this is where sometimes on your calculators, like I can take the 104 and I can just push minus, and that remembers all of those decimal places. But the 94.19 is 2 answers back. So you might have to write it out. My calculator is nice. I can go and highlight something so it keeps all the decimal places. Okay, but you might have to write it out. Now, we're going to round to 2 decimal places. So if you took 3 or 4 decimal places, you're going to be fine. Push enter. 10.69. .69 meters total. So what we're going to do, we have a quiz tomorrow, right? That quiz is not going to take all class. We're going to do one more example together. We're going to leave the 3-dimensional most difficult question for after our quiz tomorrow. Or we have 2 more questions. Maybe we'll just do 1 more and leave 2 questions for tomorrow. So again, all right, how did your picture go? So we've got a helicopter. Huh? Okay. It looks more like a dragonfly, maybe. Okay, we got a helicopter 1,000 meters above the ground. So this is the label. We've got a car that's moving away from the helicopter. Looks like a truck. At an angle of depression. Ooh. Awesome. Okay. At an angle of depression of 27 degrees. So from here to here, angle of depression is always from the horizontal. This angle is 27 degrees. 5 seconds later, it goes forward. And now our angle of depression to the new car is smaller. Does that make sense that it would be smaller? At 25 degrees. How far did the car travel in 5 seconds? So does it make sense that we want to figure out from here to here this distance? If this was straight, yeah, I'm sorry, my lines look a little bent. It would make a triangle, but it wouldn't make a 90-degree triangle. So this is the information that we have. We have to draw our triangles so that we have 2 right-angled triangles. Okay? Some people do this. So here's triangle number 1. We'll do triangle number 1 in blue. They extend this line here and this one here, and that's 90 degrees because it's straight up and down. And if the helicopter's 1,000 meters above the ground here, does it make sense that this would be 1,000 meters over there? I would also have, so that's my blue triangle with the purple line. Can you see a blue triangle right there? And if I draw this line straight up and make a 90 degree there, this would be 1,000 meters still. And then I have a green triangle. So our question is, how do we find this little black line? Can you see that that little black line is the same as this black line from here to here? So I drew 2 triangles. And I want to find that black line. Does it make sense that on my green triangle, if I find this length x, and on my blue triangle, I find this whole length from here to here, call it y. That if I did y minus x, I would get the distance. So maybe I'll write that off to the side, that the distance would equal whatever y was minus whatever x is. So, do we have enough information to find y? Do we have enough information to find x? Okay? Let's find x first. So that's my green triangle. I've got my green pen out. Oh, this number, look, this was 27, right? We want to find the adjacent side. We have the opposite side. So if I write out my definitions, for the green one, I'm going to want to use, I have the opposite side and I want to find the adjacent side. I'm going to use tan. So tan of 27 degrees. Opposite side is 1,000. Adjacent side is x. And I want to get that x by itself. It's in my denominator, though. So this is the one I have to first multiply both sides by x to get it out of the denominator. I would cancel those out. And then to get x by itself, I'd have to divide by the tan. 1,000 divided by tan of 27. Enter. Now, something very cool that a lot of calculators have is a lot of calculators have letters. A, B, C, D, E, F, G, H, I, J, K. And what that allows us to do is it allows us to take an answer, because I got x is 1962.61. And sometimes, you know how sometimes we want to keep all the decimal places? So on my calculator, above the on button, I have a store button. And I can hit that store button and it says, where would you like to store your answer? And I have all these different letters written out in green. So I can push my green button and I say, I'd like to store it as the letter X, because that's what I solved it as. I push enter, and now my calculator is remembering that if I type in the letter X, it's 19.62. For example, what is 19.62? So I'm going to type in letter X plus 2. What should the answer be? With all the decimal places. So on your calculator, if you have any scientific calculator, it will have some way to remember it. Yours has a store button too. STO. And then you have a recall button, yeah. And there's a memory button, M+. So I don't know, I have to, oh, here you have an STO, so you have a store button there. Shift to that one, yeah. And then push enter. Yeah, try it. I don't know. Maybe it remembers it. So let's see. Recall plus, here, 1 plus recall. Nope. We got to figure it out. So whichever calculator you have, you might have to look it up to see if you can figure it out. Not a big deal if you don't know how to store it, because you can always write the decimal places in. Okay? Yeah, so I don't know where it is on this one. Sometimes you can do it with memory button. So, okay. So now let's go back to our question. We just found out X. Do we have enough information? I'll take my blue pen out. Can I figure out what Y is? Yes. Again, we have the opposite side. We want to find the adjacent side. So, seems to be a tan theme right now. We're using tan a lot. Now the angle is 25 degrees, opposite 1,000, adjacent is Y. We want to get Y by itself, but it is in the denominator, so we first multiply both sides by Y, and then to get Y by itself, (1,000) divided by tan of 25, and Y is 2144.50. So the car has traveled. We have to take the 2144.50 and subtract the 1962.61 ... How am I going to do that on my calculator? Well, I've got the 2,144. I'm going to hit the subtract button. And now I could either retype in my answer for X, but since I've stored my answer as X, I can just go my answer minus X, push enter, 181.90. Does it say what to round to? No. So I'm going to round to 2 decimal places. 181.90. What are our units? Meters. How fast is that car going? Way too fast? Like, it's 181.9 meters in 5 seconds. So we could divide it by 5 and say that it went 36 meters in 1 second, which means that it would go that many meters in a minute, and times by 60, that many meters in an hour. Divide by 1,000, it is going 130.96 kilometers per hour. Okay? Right? Is this a police helicopter that has, right? There we go. I gotta stop the video.